Good morning, and welcome to Visualizing STEAM Mathematics Session 2.
I'm David Kamishlian. You probably remember me from last time. I'm a mathematics team lead.
Hi, I'm Rashmi. I'm Program Director for STEAM and Media Arts Initiatives with the Digital Team. Thank you. Give us a quick second. We are going to share the agenda for today. So again, welcome to VPS Visualizing STEAM Online Learning Session 2. This agenda for today focuses on obviously the questions that you have from Exit Ticket 2. We'll try to address them. And some of the Sketchpad activities will include discussions about functions, discussions about parabolas and its different forms. We'll also look at some animation examples and then possibly some activity around animation.
Then we gave you a survey last time of Desmos activities, some activities that I've done, but there's some really nice activities that people have already done that we're going to show you how you can use them in your class. We have 2 for elementary and middle, 2 for strictly middle school, and 2 activities for high school. And one of those activities that you'll have for completing yourself as an assignment. So we're going to really dive into Desmos, help you understand what you can use in your classroom, and use a lot of the preloaded activities.
Absolutely. We also have a teacher example, a classroom example for the Sketchpad activities. Some of you have submitted some really great screencasts, so we will have that included. And
then we'll have, depending on time, but I think we'll have the designer of Sketchpad,
Nick Jackie.
Nick Jackie, yeah, I forgot his name. Thanks.
Perfect.
He'll have some words of wisdom on what it means to draw versus construct. And as I mentioned before, there'll be homework that you should post in Google Classroom. The homework this week should be fairly easy. If you catch the assignment, you won't really have to submit anything. You'll actually be a student. You'll log in under the student account for Desmos and just complete the assignment, and then Rashmi will see that you've completed it, and we can demonstrate how that works.
Absolutely. And so it's again, we'll talk a little bit about what assignments to do, what the resources are, and the exit ticket for today's session. So let's get started. So again, moving on to the Google Classroom, this was the webinar learning session 1. The webinar for this session is posted. That's the YouTube link. You can go to that link anytime. Up in the right-hand corner, due date for all the assignments collectively or cumulatively is August 10th. We highly recommend do not procrastinate, get on the assignments as soon as possible so that there is a learning curve associated with some of the assignments, and it helps to go through the assignment before you move on to the next one. Again, today's meet links and the assignment handouts that will be posted here for the webinar learning session 2. Do post questions in your exit ticket, or you can always email us.
So there's also today's meet. So this one right here, or
yeah, sure. You can.
Okay, so yeah, today's meet. We have the URL for today's meet. It's at today'smeet.com. Is STEAM session 2.
Mm-hmm. And to earn your PDP credits, we need you to view all the webinars and complete all the assignments posted there.
And the final assignments final due date for all assignments again is August 10th. I know we've said that before.
Perfect. So here is, the first one was the mural example from last session. You saw the GSP file. We'll go back to it in a quick minute. The second screenshot is that of a GSP file which was submitted as a result of working on the assignment. Somebody submitted this as a classroom example. It's actually by Mark Williams. It's a student example, and they worked with this example, and we have that in a GSP file. So give me one quick second. We are going to switch to the GSP file. Right. Right. So what you're seeing is Mark Williams' example of the eye, the mandala, but the assignment was to use different shapes and find areas and circumference. So he has done it beautifully in here. He used a mandala model to sort of have symmetry around around his example. And again, we'll share this GSP file with you. You can modify designs and you can add to this design as well. Going back to our presentation for today. Give us a quick second. So we are looking at, there is an Excel file that goes along with the Mural project, which also allows students to work with Excel and then, use formulas and input them in the Excel file and work with it. We'll try to show that example to you at the end, so if we have time, or we will post link to that file in the Google Classroom. Questions from Exit Ticket 2.
Okay, so the first question was, we had links to the basic tools, the Sketchpad tutorials. That's been posted on the Google Classroom.
Absolutely. So we are going to the Google Classroom, and when we say that the links to the basic tutorials are posted, it's right up here. There is an Atomic Learning site, and these 5 videos about how to use Geometry Sketchpad, how to add text, organizational shape, segments, raise line tools, and all of these are posted right on this link. So if you could go to this links, go through these tutorials. They're about a minute and a half, but it allows you a good process or perspective on how to use Sketchpad tools.
Next, we got the Sketchpad tips sheet has also been posted. And I think you remember that from last week. This is sort of the, not animated, but it's sort of the cartoon, the comic helpful hints for constructions.
Right, and this is where David is mentioning those. So they are posted, and this will be a continuous process for all 5 webinar sessions. We will continue posting these really wonderful tip sessions in every session.
And so we're going to talk a little bit about what's new in Sketchpad version 5 also.
Excellent. So that was one of the key questions that came up during the exit ticket responses, is what is so different between version 4 and version 5. So we thought that it would be a great idea to include the creators of this software to talk a little bit about version 5. So give us a quick second. We are going to move to the video. Okay, here we go. Please do let us know if you cannot view or hear this, the video, and then we'll make the necessary changes at our end. Okay.
The Geometry Sketchpad is a dynamic construction, demonstration, and exploration tool for exploring mathematics across all grade levels and disciplines. Sketchpad 5 extends the software's capabilities in new directions while giving you tools to make your teaching more effective. This video introduces just a few of Sketchpad 5's new features. With Sketchpad 5, it's easy to add mathematical notation to your sketches. Start with a circle. With just a few clicks, construct a triangle using the polygon tool. Add tick marks to the triangle with the new marker tool to indicate that 2 of its sides are congruent.
We apologize. I think there was a delay in the presentation, so we'll play this video right back again.
tool for exploring mathematics across all grade levels and disciplines. Sketchpad 5 extends the software's capabilities in new directions while giving you tools to make your teaching more effective. This video introduces just a few of Sketchpad 5's new features. With Sketchpad 5, it's easy to add mathematical notation to your sketches. Start with a circle. With just a few clicks, construct a triangle using the polygon tool. Add tick marks to the triangle with the new marker tool to indicate that two of its sides are congruent. Insert the names of objects directly into your caption simply by clicking them. Sketchpad automatically italicizes the names of geometric objects. Now add the names of the two congruent angles to your caption. Click and drag from a vertex into the interior of the angle. This creates an angle marker, and the angle name appears in your caption. This hot text in your caption is linked to the objects it describes. Press the notation, and the corresponding objects flash in your construction. To test whether this conjecture is true, just measure the angles. Sketchpad 5 gives you what you need to communicate your mathematical ideas in both geometric figures and symbolic statements. Sketchpad has always been a great tool for presentations, and with Sketchpad 5, making presentations and using electronic whiteboards is even easier. Points and lines are now available in a variety of sizes and styles. Larger points and thicker lines are easier to see when you project a sketch. If you're presenting with a whiteboard, Sketchpad's marker tool makes it a snap to write and draw directly on your sketch. With its expanded presentation capabilities, Sketchpad 5 works hand in hand with whiteboards to make math easier than ever to communicate and share. Sketchpad 5 makes it easy to work with photographs and drawings. You can drag and drop pictures from your camera or web browser into Sketchpad, and then get to work. You can set up pictures as transparent backdrops and then do math on top of them. Or you can actually do math with pictures to explore symmetries and transformations. Let's rotate this once, and then a few more times, and then adjust the center of rotation to get a dynamic kaleidoscope. Sketchpad 5 offers exciting opportunities to integrate pictures into your mathematical investigations. Custom transformations give you the freedom to define new transformations in Sketchpad. You can combine Sketchpad's existing transformations or create entirely new ones. Custom transformations can be applied to any object, not just points and lines, but function plots, loci, even to your digital photographs. Here we apply a proportional rotation transformation to a triangle, and then to a picture. Use custom transformations to create shortcuts for one or more built-in transformations. You can also investigate relationships between transformations and constructions, or invent and explore new transformations of your own. Sketchpad 5 gives you lots more power to work with mathematical functions. If you're just starting out, maybe you prefer functions in y equals notation. Further along, you can plot parametric functions and even whole families of functions. You can display the x-axis in units of pi. You can intersect the graphs of functions and find the roots of. You can even define new function in their graph. Here, the marker tool draws a graph that we can then treat as defining a real function. Use a custom tool to find the area under its curve. You can even listen to a function in Sketchpad, which is great if you're building models in physics or trigonometry. All of these new function capabilities make Sketchpad even better for algebra, pre-calculus, and calculus. But with Sketchpad 5, you get more than just software. You get support materials that help you and your students get the most out of Sketchpad. Getting started tutorials walk you through the skills you'll need to get up and running. If you need to brush up on a particular skill, just watch a brief video or read a friendly tip sheet. These resources, in addition to online professional development courses, provide support tailored to your needs. This wraps up our brief tour of what's new in Sketchpad 5. Once you start to explore Sketchpad's new features, you'll see how well they work together to provide an exceptional learning experience.
Excellent. So we talked about the mural examples. We talked about some of the submission guidelines. Those were some of the questions that came up later. But before that, David, do you want to talk about the tools?
For the tools, yes. So as I mentioned, some SketchUp, but we'll see how time permits those.
And there were some submissions questions about how would you be able to submit a GSP file. Definitely some of you have emailed it to me, which is okay, but we are also looking into doing a shared Google with you, and if you do not accidentally delete an example, but we have to be sure that you can submit it. You can always email it to us, or you can also send us a screenshot of your final project as well.
Yeah.
Perfect. Moving on to, we just looked at what is new in Sketchpad 5. So sort of what the version that you will receive from us is Sketchpad 5, which is very helpful. Because then you can play with the new tools and the new modifications that have been made. Again, launching, I'm quickly going to go to the student. These are some of the examples that we've looked at before, which was the session 1. Today we'll be looking into the parabolic functions as well as the other functions. So how about we launch into one of the Sketchpad activities. Give me a quick second. Excellent. So this is a really great pre-designed activity that you can use with your classroom. This is geometric definition of Sketchpad, and you can see that it's my bad. It's a geometric definition of a parabola, and you can see that there's some vocabulary mixed into it. A parabola is the locus of points, equidistant, and here is a quick way of bringing in. Sorry, I think, yes. So there are inherent buttons in this activity where you can use that to fill in the vocabulary aspects of it. So you can have this ongoing conversation with the students. A parabola is a locus of points equidistant from a fixed point, which is called focus, and a fixed line, which is called directrix. We're going to show an example, and that allows you to see the focus, the directrix, and how the equidistant property works. What I'm going to quickly do just to enhance a little bit of this visual aspect of the equidistant property from the directrix, I'm going to go to the display menu. I'm going to say trace segment, and I'm also going to the line menu. I'm going to make the line thin, and I'm also going to make the line dashed. So this way, when I animate the point, which is point P, you'll be able to see how that parabola or area under the parabola between the directrix is getting traced, and you can see that. and it also re-emphasizes the property of equidistant from the focus and the directrix. Just a second, I'm going to stop that. To erase any traces on Sketchpad, we use the shortcut. On Mac, we use Command-Shift-E, and it takes care of the traces. I'm going to reset this, and we are going to move on to the geometric definition of Sketchpad. So again, I'm going to reset this, and I'm going to show the focus and the directrix, which is I'm going to construct a perpendicular bisector to the, just a second, from focus. We can label this point, and we have labeled it as focus, and to D, so that's the perpendicular bisector. And I'm animating that perpendicular bisector. So it shows us a really great construction and animation of how locus of lines transfers to building a parabola.
Yeah, it's very nice. Yeah, I was going to say, yeah, I like that.
Absolutely. And then we can also show a point which is tangent to that. So essentially, again, I'm going to trace that. And if you see, it's a point going through, it's a line going through point D, or right, it's following. And then you can see that it is going to be
tangency.
Yeah, construct point of tangency C. I'm going to stop tracing. I can erase traces here. Essentially, we've built in the button which allows you to erase traces without doing the Command-Shift-E. You can do the construction of locus C, which is another one that allows you to trace that parabola. And this is essentially, as you can see, the parabola is getting constructed, but you know, what you have in here is the locus of lines while you're building the parabola. I can make the directrix horizontal, and that essentially just changes, when I trace it, it will change the direction of my parabola. I can show the axis of symmetry, which is right. Obviously, it's the axis of symmetry for the parabola. I can show the vertex, which is right here. Select. I'm going to reset this. Just let me stop the. I'm going to reset this. So again, it starts with a blank slate. So if you give this activity to your students, you can go through each phases of it, talk to them about the vocabulary, the focus, directrix, where's the vertex. You can showcase it. You can move axes.
No, I think you covered it. Yeah. So this might be, at least for, I want to say Algebra 2, it might be stretching a little bit. Sometimes I know when I teach Algebra 2, I don't get to all the forms of parabola, but it's a nice, if you can tie it in with geometry, if you have an honors geometry class, it's a nice thing to tie in the geometry with the algebra topics.
Absolutely. The second one, you know, the form of parabola is the parabolas in the vertex form. Here, what you have your equation, which is you have your A, you have your H and K, and that K is your constant. But we are going to change the value of A. So as you can see right up here, the value of A is changing, and this slider allows you to change that, and you can see the variation as the value of A changes in the parabola. This is your H, which is your, do you want to?
Yeah, so the H and K, when I teach this, you can sort of think about H and K tell you where the location of the, I guess they tell you where the location of the vertex is, I guess.
Mm-hmm.
I'm saying I guess. As a math team lead, I guess I should be more specific on that. What's nice about this is that it gives the students a way, just like I know it's dynamic, but it's useful to see what happens if, and you could do an investigation where you say, what happens as H changes? What do you notice about the parabola? And it kind of drives that home. What would be cool about this is if you made both positive and negative, they could see that, oh, that's going to flip the parabola from being a concave up to concave down and so on. And
So we could move that maybe. Right from here.
So here's and this is really cool about seeing like what does A do to your parabola. Like when I teach this, I like to have my students explore and play around with this, but also have a little bit of structure where I have the questions of what do you notice about H when you change H? What happens to the parabola? Does it move up? Does it move down? How much does it move over? What do you notice about K when you change the parabola? And what do you notice about A as you change the parabola? And not so much even just saying that the parabola gets flipped, but as A increases, what do you notice about the steepness of the parabola? And sometimes people say, oh, the parabola as A gets smaller, the parabola gets bigger, and then you really got to talk about what does it mean to get bigger? What is it really? Are we talking about the size of the parabola? Or are we talking about the slope of the parabola as it goes? So this is a really nice example of that.
Absolutely. Thank you, David. So we'll quickly browse through the other aspects of it. So, here is a circle, and when we animate point B, and you've seen this animation a little bit, but this will allow you to, again, see how a parabola is constructed as the circle passes through points A and B and is tangent to the line. So, you can look at parabola and the construction of parabola in many different formats and forms. And here is, this is just one more example of that. Moving on to the next one, I'm going to quickly move this light source somewhere else. So many a times in David's class and when I used to teach mathematics as well, they used to ask us this question: where is it really applicable? Or have you seen an example of this? And this is a great example of parabola and what is the importance of learning, some of the properties and the vocabulary around it. So this allows you to sort of re-emphasize this. What I have here is a light source, and obviously a parabolic curve. And up here in the explanation, you can see, ever wonder how headlights shoot a beam of light straight out in one direction? The answer has to do with reflective properties of parabolas. Light is emitted from a light source within the headlights, then reflected off a parabolic surface towards the outside world.
Yeah, so I'm not really going to read this, but what I really like about this, and I had just seen this recently, is that what Rashmi was saying is that this really shows you an application, a real life application, and I could think of this with headlights, I could think of this with designing glasses and so on. So I'm gonna let you start it, but let's just show you how this works.
Absolutely. So if I have the light source placed at a random space, and I emit light, it is going to scatter all over the place. So think of it as a headlight of your car, and if the light is scattering all over the place, you're not going to be able to see what's in front of you because you don't have adequate amount of light. It's not focused. So I am now going to try, first I'm going to erase the traces, so Command Shift E, and then I'm going to try to move the light source to the focus of the parabola. And I'm going to show you the focus and the directrix. Now I'm going to hide it, and when I actually move the light source to the focus of the parabola and emit light, it moves in a more focused pattern. So you can actually see that the light emitting from your parabola is focused where you need it to be focused. So this is a design aspect of it that is used in many of your, as David mentioned, many of the applications. Did you want to add something?
Okay. No, I think you covered that.
Absolutely. And this is a fun way of designing your parabola. It looks pretty cool. And again, this is the locus of lines exercise. We'll try to do this if we have time at the end of the session today, or I will post a handout of this in the Google Classroom. And we can have a little bit more discussion about it next time. Having said that, let's move to the next part of our presentation. Yeah. Okay. Yep.
Wait.
So the next one is exploring functions.
Oh yeah, so this is one that as you saw a little bit with Desmos in our last session, but also Geometry Sketchpad will show you different ways of how your students can explore constant functions, linear functions, quadratic, cubic, square roots. We have cube root. That's not. I mean, you might be able to do that in pre-calc or calculus, rational functions, and absolute value functions. So we're going to show you what those look like with Geometry Sketchpad also.
Absolutely. So let's move to the Sketchpad file. Okay, we're right here. Apologize for that. We're trying to close some of our files so that we can get to it. Yes, we have a lot of them opened up. Okay, we're right here. Just as a quick note, you can add any graphical objects like the cow here. It's copyright free. You can add those to Sketchpad directly. So you can drag in an image into the Sketchpad file, just like a GIF or a JPEG image. This one obviously has a background which is transparent. So that is helpful because by default, the background of Sketchpad is white. So let's look at the first function. And this is a great use of the portfolio aspect of Sketchpad as well. As you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 examples of parent functions embedded in the Sketchpad file, which is a great way of putting together your portfolio for maybe functions, maybe how parabolas look, or so on and so forth. So this is a great use of the portfolio feature of Sketchpad. So let's look at the constant function.
So the constant function, if you notice the way it's have gone, so you might have to explain to your students that really this is a function with one variable. But as we have learned at Brighton High School, that it's really important to, if you can introduce this notation, this idea early on, that really makes it much more easier for Algebra 2 and pre-calc. So for a constant function, you can slide this and then see what happens to the function as you slide the line up and down.
Absolutely.
Linear.
Yeah, and so it is always a horizontal line. So you can add, like this is a text. You can always add text to this. So for example, you can copy a text box. You can add more details, or if you have certain specific examples that you want them to explore, you could always add that detail in here. Linear function, this is a great way of exploring linear functions. Again, as David mentioned, you're looking at y is equal to mx plus b. So you have your slope as y, and b is your y-intercept. And so in here, you have these sliders, which are allowing you to change something, and I wonder what that is. So it's obviously your slope m, and you can see that the value of m is changing. And in this case, what is the value of m? You can fix 8.7. Yes, 3.65. So it's right here. And you can keep on what happens if you move into the negative zone. So it's negative 1.15, and you can see how the slope of the line changes. You can change b, which is the constant, and you can see that the your linear function is moving along the x-axis. And this is also another important feature. Yeah, David, you want to?
Yeah, I mean, you pretty much covered it, but yeah, so it gives the students, again, it gives them a way of figuring out what happens. What is if I change b, what happens to the line? And if I change the coefficient in front of x, or the slope, what does that do? What does that do to my line? here. So it gives the students a way of visualizing that really quickly and getting understanding of oh, well, this controls how this slider is telling me how steep my line is, and this slider is telling me where does my line located, where is it across the y-axis. So those are both nice ways of demonstrating that.
Absolutely. So let's look at the next function, which is the quadratic function, and we talked a little bit about this in our parabolic function. So this is your parent function. I'm going to hide this just a second, and then you have your g of x equals ax squared plus b of x plus c, and again you have your sliders. You're moving your a, and so there are many different ways the value of a, how the nature of the parabola changes as you change the value of a, what is the nature of parabola as you change the value of b, and going also into the negative values of b and how that moves your parabola around, and see the constant, if you change that, how does that move your parabola? It moves around the y-axis, and this is a really great visualization that you can have with Sketchpad or Desmos as well regarding this.
Yeah, I didn't. You've covered it all. I don't have anything to add. Just in terms of concepts, the algebra 2, I know the way I like to teach it, not that you have to teach that way, but it's sort of nice to say, here's the parent function. Once you understand the parent function, we'll be able to go from the parent to any of these other parabolas by understanding what A does, what B does, and what C does to that, what it does to the graph. Right. The cubic will just do really, I guess, well, the cubic we don't spend a lot of time on. I don't spend a lot of time on in Algebra 2, but again, here's the parent function. Here's A, so now we got A, B, C, and D, and how do they change the function? So we can hide the parent function, and again, see what happens when I change A, what happens to the curve. When I change B, what happens to the curve? What I change C, and what I change D with the curve. I don't really think. I mean, we maybe go right to square root.
Absolutely.
So square root, I like a lot, and I know that in Algebra 2 we spend a good amount of time on it. Here's the parent function, the full function. I know we don't spend a lot of time looking at A, but B and C definitely are important. So let's hide the parent function, and let's see what happens when we slide. B. They should be able to notice what happens to the function, and then when we slide C, you should be able to notice what happens to the function. It translates up and down. And just a helpful tip on this is that what I like to do is I like to relate this back to, remember in geometry where we talked about translations? Well, translations happen to functions also, and so that's what's happening with C. We're sliding, we're doing a translation that moves the graph up, vertically.
Absolutely. So that's a very good point that David mentioned, sort of bringing in translations to the existing concepts of graphs. Just a quick pointer in terms of working with Sketchpad, especially the sliders. The pink area, when you select an object on Sketchpad, it essentially has this pink hue on it, and that is what selects the object. So if you want to use the sliders, preferably use the end point, and that will allow you to slide it through. You can do the same thing with the buttons that are placed here, and then this little arrow that turns into a horizontal arrow will allow you to move them around. This is a text box. Again, a horizontal arrow will allow you to move it around. But if you see, two of the objects are selected in here. I have the text object selected, which is pink, and then I have the show parent function object that is pink as well. So when I try to move this object, it is by association moving both objects together. So just being mindful of that. I have to deselect. You can deselect by clicking anywhere on the Sketchpad screen, and then select, move it, and then you can move individual objects. Just a quick tip.
Yeah, I just want to second that. I think for me, when I first started off with Geometry Sketchpad, with the thing I really had to get straight was what's selected and what isn't selected. And sometimes when you move things, it's like, wait, what happened here? And it's because whatever you picked last, you forgot to deselect it to select something else. So just be mindful of that.
Absolutely. Do we want to talk? Oh, next function. Let's look at the.
This one I think we can just do
Quickly.
real quick. I know students will have to know what the cube root is, but maybe some of you guys spend time on what does it mean for the general function for a cube root with the here for you guys, here for you to use if you need to use it.
Absolutely. The next two are actually we'll look into let's say absolute value function.
Good, yeah.
Okay. Here is the parent function. You can see that, and we are going to show you the full function. Moving the how does the function change again as we move the parameters? So a, then we go negative into changing the value of a into the negative values, or b as we move it. How does it move? Does it move around onto the x-axis? Yes, no, those are the kinds of questions you can have with the student. That's a point of discussion. And as I mentioned, in Sketchpad, you can also have some existing questions. And when you give this to your students, those could serve as prompts for the student to answer based on those discussion questions. Again, here I'm changing the c, which is the constant, and you can see that it's moving around the y-axis. And again, this is another discussion question you can have with students.
Yeah, and again, to sort of hammer home the notion of what a function is and what happens with these values, this is really nice in that you can go here and say, well, okay, what happens when I slide when I change a, and a goes negative and a goes positive, and same thing with a, b, and c. And if we go back to the quadratic function, we have the same a, b, and c, and you can say, well, let's look back at the parent function. I'm going to hide this and go back to the absolute value. Here's my, and relating these two, like this, the concept of this isn't too hard to say, well, I know absolute value of -1 is 1 and so on, and then looking at it and saying, what happens when I change these? And now taking a step up and saying, okay, we have a, b, and c that we have sliders for here, and how does it change the graph? Quadratic, let's see. Oh, we have an a, b, and c, and see how the a is outside the x squared and have a b and a c. What happens with a, b, and c here as it changes the graph? And getting students to relate that there's a certain thing that happens that is common between these functions for different graphs. So I just wanted to point that out. And then lastly, we have the natural log function, which students should be familiar with. Maybe you guys know more than I do about whether or not we show them the transformations of this when we change a and b and c. You can see that it's very similar to what we do for the quadratic, for the square root and the cube root.
Right. Perfect.
And I think the last one was the exponential.
Exponential.
And exponential, I'd like to relate. I myself like to relate it to sort of like a linear, just because you have an a here and you have, I normally take a and I don't worry about b here and just c, to where a is really tells you sort of what the what the slope is, if you want to think of it that way, and what c is sort of your intercept, your constant where you're going to cross. So if you notice, that's kind of the analogy I like to use here, where it's, oh, that's where I'm crossing the y-axis. A really tells me how steep do I make that curve, sort of relating it to the slope. Well, the y equals mx plus b.
Right,
yeah.
Not entirely, but that's a really great strategy to use, because students have seen some of the functions before. They see, for example, as David related the exponential function to the linear function, they've seen the linear function, so it doesn't feel daunting when they look at exponential function and start differentiating or comparing and contrasting. That's a great strategy as well. So that sort of brings us to, let me quickly go to the, I think I closed something. Give me one quick second. I'm going to share. I'm going to share the presentation. Okay. So moving on to our next activity, which is our animation activity. The activity that you're seeing here on the screen is something that you will be creating. Of course, we expect you to create one of these and not all of these, but it's a great little tool to play with, as you're learning some of the concepts in Sketchpad. So let me quickly switch to that. Yep. And this is, oh, give me one quick second. I'm going to present to everyone. Yes. So this is a great little tool to, let me get to the file. Yes. So this is a great little tool to learn a little bit about animation in general. So we are going to, literally the instructions are written down in here, so you can give this file to your students and you can ask them to follow through, and as they have questions, you can always help them with what needs to be done, or where do they need to go into their display menu or toolbox in order to do this. So this one literally starts, step one is draw a circle. So I'm going to take a circle and I'm going to draw it right here. I'm going to make this screen a little bit bigger. And as David had mentioned it before in one of our Sketchpad activities, whatever options we choose before we start using a tool, they have a tendency to stay with the tool. So for example, remember in that parabolic animation, I chose the segment which was from the directrix, the equidistance segment. I made it dotted, and then I made it sort of, in this, that was my property of that line. Any object that I draw will retain that property unless I go in and change it into my menu. So I'm going to go to the line style. I'm going to make it thick. So, and I definitely want it to be solid. So I'm going to change my line style to solid. So now I have a solid little circle. And the instructions say draw a circle, label the control point B if you move it. So how do we label? There is, we select the control point, because I know this is my control point, because by dragging it, I can see that I can make my circle bigger or smaller. And once I select it, I can go to my toolbox and I can choose A, which gives me this nice little finger. I can click on it and it gives my circle's control point a label, which is I. I don't really like that label, so I'm going to double click it and I'm going to go into properties option. And when I go into the properties option, it gives me a label option, and I'm going to label it as control point. I could also label it as David, but for all purposes, I wanted to say what, or I could say C if that makes more sense. Whatever you prefer and is a logical label. So point C and choose animate point. So I'm going to construct point C on the circle. I can literally take a point, I can go near the circle, and whenever there is an intersection happening, the circle will turn this red, hue of red. I'm going to place that point on the circle. Just to make sure that the point is on the circle, I'm going to rotate it around the circle and it does not really leave that circle, as opposed to a point which I will probably place when that right hue does not occur. I placed it here, and this point is not really an intersection because it can go anywhere. So just being careful about how we have these intersection points placed or defined or constructed on an object. So let's say that's my intersection point. I have to label it C. Give me a control point. So here I'm asked to change the label. So give me 1 second. I'm going to change it to B according to the exercise. And I'm going to change this to C. And select point C and choose animate point from the display menu. So I'm going to literally select point. See, it didn't label it. Give me a second. I didn't label it.
Oh, I wonder if it's hidden. Because I do
Yeah.
that. Do the.
Yeah, the display, hide, show all hidden. Oh,
No, I think I was going to say if it's just go to properties.
yeah, show label.
Yeah, show label. There you
Yeah,
go.
okay,
That's it.
perfect. So yeah, there was a little bit, it's sort of hidden. You have to explicitly say show label and it will start showing the label. So we have C. Now I'm going to animate C. So I select C. I go into my, I'm going to right click it and it will give me an animate point. So literally there is a motion controller box that appears and this point will continue moving on to that circle forever up until either you stop it or the software crashes. So I'm going to stop it because I don't want it to crash, but then I can create a button using the same logic. So I'm going to go in again, right click, and gives you an option of 1 second, center value for point. So I might have to go into, just a second, create, I think, point toolbox. So let me quickly go to, so I could do this. Give me 1 second. I'm going to go into selecting this, copy, Command V. So let's see, properties, object, right? So it gives me in the properties, I have an object, and it will allow me to do parent circle 2, hidden, arrow selectable, okay. And I'm going to have to create the button a little bit later just because it's not giving me that object option right now. But having said that, the first activity is essentially, you get some idea of animation. So I selected, I make it move. So you have a motion controller box that allows you to animate the point. Then comes the next step, which is now construct CA, so on and so forth. So if I go to construct CA, I'm going to go to the construct menu, segment. Everything again as inherits the property of that line segment, which is, it's thick, and it's literally going to continue with that property unless you go and change it. So I'm going to go into my display and I'm going to change the line style to dotted so that I can see it separately. And then if I now trace it, there is in display, you get an option called trace segment. Then when I do the animation of this point, it will trace a nice little circle within circle animation, and it will continue doing so until I stop. And this almost looks like a dartboard. So things like that. And again, you play with it. There are 7 steps. You will have this as a part of your homework. I will quickly go over it next time if possible. But we'll also have like a screencast of this posted in the Google Classroom eventually. This is essentially one of the animations that you will be creating. It's a really cool one, but I think it's kind of a starting point, and you should explore more, change properties around, and you'll see that the animations vary. Do not forget Command Shift E, because that allows you to get rid of the traces. This is another one, animate points. And you can see that there is some variation in terms of how you're moving around on the screen. And again, it's properties, change the properties and play with it. Command Shift E will allow you. So that brings us back to our sequence. Give me one quick second. I'm going to close this file, so give me one quick second. I keep on asking you for one quick second, but and we're going to close this. Yes, there are a lot of files opened on our screen, so we don't want to, open up a wrong file, so that because you'll be viewing that. Okay, so moving on to our presentation, we'll talk about this example, sum of exterior angles of polygon. Kevin has submitted this resource. David did this activity with one of our webinar sessions.
Oh, yeah.
So you can always watch that activity, and David will also give a bit of feedback after we see this activity as to how he uses it in his classroom. This is a screencast, so please feel free to submit resources, something cool that you do in your classroom. A video file or a screencast of the activity, classroom activities, is highly desirable, because then everyone can play those activities as well, or they can use it as a resource. So quickly going back to the activity, just a second. And after this, we will move into Desmos and really fun activities. Just a second. Sorry. I think that's the one.
Yeah.
Yeah. Okay. Okay. We are in here, and I think okay, we're going to play this. The volume on this is a little bit low, so please bear with us.
Gave the sum of the exterior angles of a pentagon. First, we need a pentagon. Use the ray tool to construct it. By using the ray tool, we get the exterior angles for free. To find the sum of the angles, one approach would be to measure all 5 angles and use the calculator to add them up. To measure an exterior angle, use the point tool to place a point on a ray, and use the arrow tool to select the 3 points that designate an angle. Choose Measure, Angle to make the measurement. To do this for all 5 angles will take a lot of work, and the result may be hard to remember. Today we'll take a different approach using transformations rather than measurements. First, a bit of background. The arrow tool you normally use does a particular kind of transformation. What is this transformation called? This transformation is a translation. Observe its effects on the pentagon. Do the lengths of the sides change? Do the angles change? Because the lengths and angles remain unchanged, we say that these measurements are invariant under translation. Translation is not the only transformation the arrow tool can do. Press and hold the arrow tool in the toolbox and choose a different arrow. What does this arrow tool do? What is this transformation called? This is called the rotate arrow because it rotates objects about a center. When the pentagon is rotated, do the side lengths change? Do the angles change? Both lengths and angles are invariant under rotation. Now try the third arrow tool. What happens when we drag the pentagon with this tool? This is called the dilate arrow because it dilates objects about a center. When the pentagon is dilated, do the side lengths change? Do the angles change? sum of the exterior angles of the pentagon. When the pentagon is shrunk almost to a point, we can see that the rays all emanate from that point, and the sum must be 360 degrees. Without constructing it, can you say what will be the sum of the exterior angles of an octagon? How about a 20-gon? So there's no need to memorize a formula. You can just remember that when any polygon is shrunk almost to a point, the rays emanate from that point, and the exterior angles must add up to 360 degrees.
That's nice.
Excellent. Give us a quick second. We're going to go back to our presentation.
Yeah, that was better than the one I did. I like that.
So thank you, Kevin, again, for sharing one of the classroom resources. David, do you want to add?
Like I said, I think that was better than what I had done. Like shrinking the polygon down really draws home the point that no matter the number of sides, you still have to go all the way around it. So it's always going to be 360 degrees for some of the exterior angles. I just did one where I did the work that he was saying. Yeah, so much like you had some of each of the angles, and you write that expression that adds up the angles, and you change the shape, and you notice the sum is just always 360.
Absolutely, and I also like the fact that Kevin, you included discussion about translation, how dilation, the properties are impacting, this activity, and how bringing that conversation in as well. I think David did that before with functions, and how you can bring prior knowledge into exploring other functions. So that's a really great strategy, just as an instructional strategy. So just wanted to point that out as well. Moving on to our next activity, we'll be going into Desmos. So give us a quick second. David, do you want to?
Yeah, so let me just say, how we're gonna, how we'll proceed from here. So there's a bunch of different activities we wanted to demonstrate with Desmos, but also wanted to give you an idea of how to, just say if you're new to this, how it's organized, maybe an introduction on how you can search for activities, how it's set up, how you could use it in your classroom. So we have 2 activities for elementary and middle school, 2 activities for middle school, and 2 activities for high school. The first 1 or 2 activities, what we'll do is we'll show you exactly sort of step by step, really give you a feeling for how you can set it up, where you tell your students to go for the URL to do the activity, and what you'll see on your screen with all your students logged in. And we'll do that, I think, for maybe one of the first 1 or 2 activities. But then after that, we'll just sort of assume that you understand that, and because it'll take a lot of time for us to do that with all 6 activities. So so first, let's go to.
So let's go to the modeling parameter. Sorry.
I'll tell you what. Why don't we start right up with Desmos? If you want to just log off and log on in Desmos, and we'll.
Okay, that's a good idea. Let me just get. Oh, we are already in here.
That's okay. I think if you log off and then log in.
Right. It's going to take us some. So okay, sign in. I will just sign in using my account.
Okay.
So I'm right in here.
Okay, so just to point out, so if you notice, this is going to be, maybe I'll let you draw. I'm like a mouse. And so my apologies. I'm used to doing a mouse. So you can start your activities if you want to scroll.
Absolutely. So these are our activities.
Yeah.
We can start with
and if you want
modeling.
to, and we'll click with browse activities. So there's a number of different activities that are here. And if you notice up top, you can search for an activity. You can look for different activities here.
Area.
Yeah, so if we look for example, area, one of the activities we're going to be doing is this modeling perimeter and area. But let's say you didn't know what that activity is. You can certainly click on this. So when we click on modeling, and if you notice what comes down, oops. Yeah, let's.
Yep, go ahead.
Yeah, so once you just, so if you notice what happens is it gives you a description of what the activity is. It says whether or not you've used it. So if you look off to the right, there's a code that says, oh yeah, you've done this once with your students and this was a code. And as a teacher, you can go back to this code and see what students participated and did. But what I like about this is that there's a description. It gives you words, words that might jog
Keywords.
Keywords or vocabulary about what might help you decide whether or not you want to use this. Let's say I don't know if I want to use this or not. I usually click, what I've done before is I click to learn more. And what's nice about this is, let's see, I got to do, but if I scroll.
Just do that.
Okay.
Yeah.
This is, okay. So, and so you have the same description, but here what they do is they show you all of the screens that your students are going to see. And what you can do is preview this and say, well, I'm not really sure. I want to run through this myself. When you run through this yourself, you don't really get a confirmation of what you're doing is right or wrong, but you get an idea. You see exactly what the students are going to see. So the first one would be, say, pick a number, 10 to between 0 and 20. Here's the next thing they're going to do, and so on. But what's nice about this is you get to preview the whole thing before you get your students to do it. Okay.
Absolutely. And as David comes back to the activity, there is this little star here on the right hand corner. As you can see, it's a golden. When I click on it, it turns golden, so we get a gold star. But it also includes this activity into your favorite activities, so or starred activities, and it's right there available to you to use. So just remember that neat little trick. And when I go into an activity like this, it's sometimes, give me 1 second, when I create like maybe when you talk about new session, I can point out. Yeah, go ahead.
Okay, so what we're going to do here, and I want you to be a little bit patient, because we really want to demonstrate, we don't have a class of 30 students, we have a class of 1 student. And so we want to show you what that's going to look like, both from the student perspective and from the teacher's perspective. So I'm going to click in here. This was the first activity we're going to do. And remember I said this was an elementary or middle school. And what I'm going to do is I'm going to click new session. And this means I'm going to start a new class with this. So I click new session. And if you notice right here, this is what you see as a teacher. Here's what your students are going to click. And in fact, what your assignment is going to be for tonight is going to be, I guess we can say, yeah, we'll use this.
Yeah, absolutely.
But you'll type, and this is on the slides, and what your students will type is they'll type student.desmos.com, and they'll use this class code. So
both of us will join that
you
class.
Want to do it on this?
Okay.
Okay, so I'm going to do it.
So I'm going to go to https student.desmos.com, and I'm going to type in 7RRJ. And I'm going to say join. Yep.
And I'm just
takes a little bit of time.
7RR. What was it? 7RR.
RJ.
J.
I think it's capital. So although the class code that you see is capital, it is case insensitive, which means you can do, you can type lowercase as well, and it should be fine. It should work fine. So I am joining that modeling area and perimeter activity. How do I, as a teacher, know that you've joined in? So David has joined in, and I have joined in as well.
Okay, so and this is, again, this is what the teacher will see. If you notice the 2 right here, it says that this is where your 2 students are. The little slide bars here tell you how far your students have progressed, and you can even click on this and see what your students have done. Now, it's going to be a little bit, you'll only see this, but because we're demonstrating this in this webinar, we're sort of going to bounce back and forth just to answer the questions, so you can see the progress. So do you want to do yours, and I'll do
Absolutely. So let's say, what is the first activity? It says pick a number. So I'm going to pick a number David, which number do you want to pick? I'm going to
I'll
pick
pick
10.
5.
Okay, I'll pick 10. So we did that, and it says, I have other student also answered it. So let's see, I'm going to go to the next activity where it says, sketch a rectangle that has your number as the width in inches and a length 4 inches greater than that. So I'm going to start doing that. I'm going to press a rectangle. And that's as best as I could do with the freehand design. So I want the dimensions to be, it will be 10 and 4 more, so 14. And I submitted it to the class. And David did so too. And when we go ahead.
And
David.
so what's nice about this is you see the slide bar has gone a little bit further. If I click here, you can see you can see the name. And what's really nice about this is you're going to see all your students and what their responses were. I haven't played with this, but let's look at overlay. Here's what Rashmi did. I know I drew a better drawing, right? But you can do an overlay. You may not think this is so nice here, but when you're doing graphs or another one we're doing where somebody said, oh yeah, the point 24 is here, and somebody said the point 24 is over here, and so on for a coordinate graph, you can see all 30 of your students and where their response is, okay? So just sort of getting back, we'll just do one more, maybe we'll do one more question on this just for you guys to get the feeling for it.
So let's look at the second question, which is represent your rectangle as a point.
So we're going to say your width. So I'm going to plot the width and the length of the coordinate pair. So the width of mine was, I think it was 10, right?
Right.
2, 4, 6, 8. Oh, and you have to be careful of scale here.
Yep.
Why did I pick 5? 2, 4, 5. Mine was 5, 9. 2 odd numbers. So 5,
and it was 4, right? 14. It was 10 and 14 for me, and yours was 5 and 9. 5 and 9. Oh, you got the good ones. Where is my 10?
Enter your rectangle's dimensions.
Where's my 14?
Oh, here we go. You know what we're doing? This is embarrassing in webinar.
Right.
You type it in as a coordinate point. So I'm going to say 5, 9.
Oh.
And you type.
Yep. 10 and 14. So paste it. Okay.
And now if we go back, and this is really another benefit. If I
Did
go.
I submit? Oh, maybe I did.
See, it looks like 2.
Yeah.
And what's cool about this, and this is what really is another power of Desmos here, is if I do overlay now for this, let's see, we should have. Okay.
If you go down, you'll probably see the points. Yes.
Oh, there they
go
are.
up. Yep.
Oh yeah, so let me shrink down the scale.
Yeah.
And if you have 30 students or 30 students, what am I saying? 27 students or 20 students, and they pick different numbers, you'll be able to see all these points. And then you can talk about what's the relationship between the width and the height for this, okay? So again, this is, we won't do this for all of them, but just to give you an idea, you have your students over here. You can click on one of your students and see what they've done for each one. You can see what
they may not be able to see that window.
Oh, which one?
The one that came up. So you might have to go here to show them the. Yeah, it's.
Oh, okay,
yeah.
Okay. But again, the class code, and then when the students finish. But this is just there's a number of. We're going to go do these for, like I said, two for each grade level of Desmos. But what I really like about this, and what I'm going to be using this fall, is you can do this on Chromebooks where you have all your students here, and you can have your own computer where you say, oh yeah, let me click on this, and I'm going to know what all my students' responses are. So if you have 20 students and you have 20, you can have 20 graphs here, or you can put questions in. Desmos also has a place where you can answer questions, or just like what we did for the previous one where you type dimensions, you can look at all your students' responses, okay? So This code right here will keep this open. This will be what your assignment is for tonight. Is you're going to type, and it'll again be on the slides, the webinar, but you'll type student.desmos.com, and you'll type this code set, and it'll come up with a prompt, and you'll type 7RRJ. It doesn't matter about the cases, and please use the name that you've done for registering for the PD, so we'll know that you have credit. And then Rashmi will be able to see. We'll be able to see all the students and them completing that class. Okay.
So one quick tip, just in terms of, if you see this grayed out D right here, this brings, if I click on this, this brings you right back to the main page of Desmos, where, you know, if you have like 10 activities that you've planned for the day, you could actually go in right there. So when I go in here, it brings me to that main page, and then we have all these activities scheduled for you for this webinar. So give us a quick second to give you a preview, or maybe David, do you want to launch into the?
Yeah, why don't we? So let's do the second. Well, I want to. Last time, I apologize, guys. I got ahead of my slides, so I just want to make sure I don't do that.
That's okay. So we have. How about we just go into the activity, which is number 9.
Do you want to do the peaches?
Oh, the
I think
peaches.
this. Yeah, I think this was the second.
Let me. Would help us. Give us quite quick second. We're going to go into our sequence. Is that now?
Did we lose it?
I think we closed it, did we? Give me a quick second. You know what? We are going to go back to the Desmos classroom while I open up our presentation. So we'll be right here. Okay.
Oh, okay, there it is.
So we looked at, you know, the studentdesmos.com, which is, you know, essentially will give you the class code, which will be the one that we mentioned. And then the modeling perimeter and area activity is what we did some exploration in. This is the activity that you'll be doing for the homework. So completing the next 6 or 7 steps of that activity. The next one is?
Yeah, so the next one here is how many peaches. And I like this one. This one we said can be done in elementary or middle school, but also for high school. One thing that I've gone through, I don't know if people are familiar with Joe Bowler, but there's these things called math talks. And this really sets up a math talk in terms of finding out how students group things. Like initially your students may be a little bit hesitant and say, well, I just counted them all. But if you really push them to think, they're going to tell you different ways they've grouped these. What I find is really powerful, and I've done this in my Algebra 2 class and in my Algebra 1 class, is that students see different ways of grouping. And the really powerful thing about that is that there's not just one way of counting. There's not just one way of grouping, and you use the ways that work best for you. So we're going to do this. I'm just going to show you very quickly what this is for how many peaches. And this one isn't really so much, it's really a shorter activity. Am I here?
Yeah, perfect.
And so again, I selected it. I'm not going to do a new session here. I guess I could, yeah. We could. I guess we could do a new session. We'll just step through it again. We're not going to do it with the students, but I'll just show you. Well, I'll just say to learn more, and we'll look at the slides. So again, here's what your first slide looks like. How many peaches are in the graph in this photograph? You submit this to the teacher, and the teacher will be able to see how many responses there are. The other thing I was going to say is, what some of these lessons have are tips for teachers, and on some of these that we'll do later, they'll actually have the answers for some of the that you'll be able to see of checking off the students. But here's a nice tip that this teacher put in, where you can relate some of the properties of mathematics, like the commutative property, the associative property, area, or connecting those to how students have counted these. But this is also included in your Desmos lesson. And it says here, use a sketch tool to illustrate your thinking. So you could say, maybe the students is going to say, well, I counted all these that went all the way. lousy with the mouse, but I counted all these first, and then I counted the ones in the middle and so on. But I really like this, and I think I really strongly encourage you guys to do, if you're not going to even do Desmos, to do something like this where you have a number talk. They're called number talks.
Or they could even count as 4s or 2s, or so just sort of giving them that room to develop their strategy and then talking about it.
Yeah. So and this is just a nice way of having an interactive way of where students have come up with their thinking. And the other cool thing would be that when students say, how did you see it, and they have sketches, you could throw, as a teacher, if you have an in-focus, you could put all those different ways of how people have done it. Like maybe one of your students counted by 2s. Maybe one of your students grouped them and said, oh, there's 4 there's 1, 2, 3, 4, 5, 6. Maybe there's 6 columns and so on. And if they draw those, you can put all those up on your in-focus and say, hey, these are different ways. And it's really, I can't emphasize enough, it's really a powerful way when students come out of your class and say, oh, I didn't think of that way, and there's other ways of thinking about it. And maybe it's some student who thinks they're not good in math or they haven't done well in math, but they've grouped it a different way, and it's really a nice thing to emphasize, to really encourage that, oh, you came up with a different way that it's a way that works for you in terms of grouping. So that's it for how many peaches.
So let's go back to Desmos.
Oh,
that's our classroom.
Oh yeah.
So we'll go back to Desmos, and then we'll go to the.
Do you want to go back to slides? Or?
Right.
Yeah, okay.
So let's look at the third activity. Is designed to probe students' sort of sense of numbers and their magnitudes. Teachers can facilitate class discussions related to scale and relative magnitude of increasing large numbers. There are 3 sort of Desmos activities that you could look through and browse through. So there are, at various points, you can actually use them, but we'll be focusing on the first one. And here you go.
Yep. So here's we're just gonna quickly do number line. This one you probably could use for elementary school, definitely for middle school. It's where they really get a notion of magnitudes of numbers, order of magnitudes for numbers. So I'm just, again, going to do the learn more for this. And if you notice, again, this has to do with the number line. So I'll click the first one. And here, what you'll be able to do, like instantly, with a number of your students, is it says, where's number 1 on this? Move the red point. I could estimate wherever I think this is. You'd be able to look at this as a teacher and look at your students and be able to diagnose and assess, oh yeah, most of my students know where 1 is relative to if this line was 10 units long, and so on. This is really kind of just a short one, but again, it's like, where is 10 on the number line, and a discussion point for that. And again, we have tips for teachers. It says use the overlay mode. Overlay would be really nice because you could look as a teacher, you can say, oh yeah, all my students are clustered here. Maybe there's 1 or 2 that put a point here. Can we have a discussion about that? And you have all that information right there in front of you. And again, if you could display it on an in-focus, be able to discuss, hey, a bunch of you had it here. Tell me why you picked that area. What was your reasoning for placing your point where you placed it? So again, I really like that.
Yeah, I like it too. I used to have a teacher in upper elementary who had used this, and they used to use the what is it called, the transparencies, and they used to do that activity.
That's right,
and it is incredible to have this tool right up in the computer and use it that way, because it was enormous. It does re-emphasize your understanding of the concept really well.
Okay.
So, thank you, David.
Yep. Oh, thank you. So it's this
next one. Yep. And then we just go.
All right, so the next one has to do with the coordinate plane, and if you're like me, you see sometimes that your students get confused with what comes first, the X or the Y value, and so on. So we'll look at that one next, and this one's definitely a middle school activity.
Mm-hmm. So we go to Desmos, yep, and then we go down.
Oh yeah. So I do 2.
Yep, just 1, and then we go. It
think that was,
is, yeah, and I think it's
Yeah.
right here. Perfect. So we'll do a lot more?
Yeah.
Perfect.
And again, this one, it gives you sort of like, we'll do the preview and so on for this.
So before David goes into the preview, I just wanted to point out that we have this share with other teachers. There's a link that you can, you can literally use this link, embed it, and share it out. So if you are suggesting some resources, you can just pull out this link right away, and you can share it with us, so it becomes a collective resource. You can also tweet about it, so others in your group can know about it. Or so there are ways in which sort of you can use this activity, or you can build your own activity, modify this and build your own activity.
Yeah, that's what I was going to say. Is the activities that I built are implemented. I showed you yesterday. Once you finish with your activity, they ask you if you want to submit it, and if you choose to submit it, then I haven't submitted any, but I assume that they would put it in a list of all the other ones that are available to other teachers. So again, this one is really coordinates plane. So click on each point to show the coordinates. Drag the point to its x target. So if I click on,
can they see this? Let me see if they can see this. Yes, they can see this.
Yeah.
Okay, excellent.
So if I click on the point, this tells me it's at 0, 0, and if I drag it to, now they understand, or hopefully they understand that, oh, if I'm just moving the point left to right, it's just changing that first number in my pair. And so if I drag this one, I click it, that's 10, 0, and this one's at 2, 0, and I slide it. But and it won't keep going on this, but again, it's the power of this is that it's engaging for the students, but also you get a way of seeing all of what your students are doing at the same time, and being able to show that up on up visually for the whole class to see. So let's see. I'll click on each point. Oh, did you want me to?
Right, or we can move to the next.
Oh, okay. Let me do.
Yeah.
Okay.
Absolutely.
Let's see.
Yep.
So high school, I picked 2 activities, but there's other ones that you could have picked. I picked one that's called Match My Parabola. I noticed when I was searching, there's a bunch of different Match My Parabola, Match My Polynomial, Match My Line, and so on. They're sort of engaging.
It's a series.
Yeah, it's kind of engaging for different students to do. So I'm going to pick. Oops.
Right. Just a second.
Oh, sorry.
So we are going to quickly make sure you see all of it. So, and we are going to the Desmos. So we can take a look at Match My. So as David mentioned, we had Match My Polynomial, and then we have Match My Parabola.
Yep. So we'll just do this one real quick. Learn more. And this one I kind of like was more pretty. Oh, can I?
Right. I'm just observing this.
Oh, I'm sorry. Yeah.
No,
I'm sorry. So this one I kind of like because it's the instructions, so it's a little bit more instructions. And you might think of this, I wouldn't start off with a parabola with this one, but this might be a review after they understand what parabolas are. They start off and they say, match my parabola challenge. You want to plot a parabola that passes through the 3 points, and it says click the arrows to get started. So your students would see this. And then they got these 3 points. And so for this one, it gives them a way of saying, well, maybe I think it's, I don't know, 2x. And again, if I click here, where's the keyboard? I want to do, the tip for teachers. I'm going to just slide this over. I'll slide it back here. Yeah, here it is. I'm going to do x squared, and I say, oh, I got the center point, but I didn't get these 2, and I have to maybe adjust it. Or could I adjust it by dragging or things like that? So this is definitely Algebra 1 and definitely Algebra 2 if you want to review Algebra 2 concepts for parabolas and things like that. It would be really useful. Let's see. I'll slide it over.
Right. So we'll go to the.
This will be the last one, I think. Yeah.
Yes, next session. It is match my polynomials, and it's of course a high school activity. Sort of again goes back to your match my parabola, match my linear equation sort of activities, and it gives you the polynomial challenges, polynomial functions, and sort of helps build understanding of roots, behavior, multiplicity, and vertical dilations. So we are going to look at the activity. Go to Desmos, and we are looking at, yep, there you go.
Okay, I was just making sure.
Move this so you have more space. Go ahead.
Okay. This one. Oops. And here's sort of a review of roots of a polynomial and so on. So if I do preview for this, so you have to replace the number signs with places to match the graph below. So if you look at it, it crosses at -5, crosses at -1, 2, 3, crosses at -3, crosses at 1, and crosses at 5. So this -5, that takes care of that one. This one looks like it's
-3.
Yep, -3. Let's see if I do this.
Delete.
Let's see. Why do I feel like this is not right? But that's okay. We learned through our mistakes. And then x minus 5. It looks like I missed one here. So I got this one. I got this one. I got this one, but I got something like this.
So do plus.
Yep. Yeah.
Yeah. So it's negative of, yeah. Perfect.
Yep. Yeah.
Perfect. David gets
Right.
a perfect score.
On this one, I guess. As a math teacher, I should, although I have no problem making mistakes. My students love when I make mistakes. So again, this is another activity that you can do, and you can see what your students respond with for these, these questions and so on. But it's sort of the same idea. Some of these, as they get harder, they'll give you hints and so on. And when you make your own, you can type in text here. You can type in equations. You can do what you want for these. And I guess that's it for this. I'm going to just sort of change. I want to do one other thing that we haven't talked about.
Oh, absolutely, absolutely.
I showed you these, and a bunch of these are graphs. I was just going to search for ones because I just want to show them a couple of different activities that don't have graphs that are still really fun to do and useful mathematics.
Right. I think our session got frozen. Give me 1 second. Give me 1 quick second. We are trying to get back into our. Give me one. Yeah.
Is it that one or is it the
So it opens up. It opened up all the sessions while you were scrolling. So it's trying to open up.
Oh, sorry.
No, it's okay. It brought all the. Okay, so. Not going to our. Okay. I think we are back in our. It opened up a different desktop, so we are going to take a quick second, and we're going to try to go back to our presentation.
Okay. I just want to show them a couple of things
Absolutely.
that are not graphs.
Absolutely. So.
Okay. So can we? I just want to. Can we?
Yes. I'm just going to quickly zoom in so that we can see. Yes. So we are in a bigger screen space. Okay. Excellent. Okay.
Okay. And I was just gonna, if we scroll down.
Okay.
Okay. Okay, so I want to, oh, this is,
I'll scroll.
okay. So I'm going to just show you, these weren't on the agenda, but I just want to point out some of the other activities that you can do that aren't graphs that are really engaging. There was one I was going to do, but it didn't have a preview mode. This one right here, I think this one was really interesting, and it just gives you an idea of that you can do a bunch of other things. You can do some other things with Desmos that aren't necessarily graphs. I'm going to just start off a session. It gives you a nice description of this, but basically, I'll just start off the session. What you're doing is you're collecting data and you're trying to figure out what's the relationship between the number of pennies that will fit in the circle as the circle gets larger. So why don't we just start a new session?
Yeah, so it's going to take some time.
Okay. Not sure if, well, maybe we can't do this because we have to have a student to do it. But
so how about we'll try to include this activity, considering our time constraints right now. We will try to include this activity in our next session and have information about this activity included on Google Classroom.
That sounds good. Sorry about that, guys.
Oh, absolutely. So this is again going back to our classroom. We will have a similar webinar learning session 2, which will have links to all the activities that we mentioned and worked on into this session. They will be linked over here. Going back to our presentation, we looked at Match My Polynomial from the high school activity. We will post Nick's words of wisdom. They are really great in terms of draw versus construct and how that is implemented and is very helpful to students. But we'll post this really nice screencast into our Google Classroom. So please if you have a minute, please watch it. Obviously, this is not part of your assignment. It is optional, but we highly recommend you do. Coming back to our MADLCS curriculum framework, just making sure that a lot of these activities are well aligned with the curriculum frameworks. So you are focusing on in addition to the core mathematical standards, you are implementing the computational thinking standards into the curriculum, and these are really great activities which allow you to think about iteration, think about dilations, transformations, and that allows you to look into this different modality of thinking on these standards.
Okay, so we mentioned for the homework, we'll change the class code to reflect
Right.
the one that we just did. But your homework for this session is you want to make sure you complete the animation lesson. That was the one that Rashmi had talked about, where the steps are really getting you comfortable with doing the constructions, doing the animation, labeling points, and selecting and deselecting things. The second one is really it's you going through and doing the modeling perimeter and area lesson. So we'll update the class code, but you're going to log into student.desmos.com. You'll type in the class code and then just go ahead and submit your answers to that. You won't be graded on it. It's just that I'll just give you a feeling for, hey, this is what it means for as your students do for what your students do for Desmos activity. It would be nice if you could get together. I mean, if you guys could collaborate and maybe say, hey, let's all do this one Desmos assignment, and then one person could be the teacher and watch what the other students respond. I mean, it is very powerful to see what all your students are responding for their answers for each of the questions.
Absolutely. And of course, there is an exit ticket, which is just basically a couple of questions. And all the resources, again, that we discussed during this webinar session will be posted on Google Classroom. So please do go there if you haven't already. August 10th is your deadline for all submissions. But we always say, please do the assignments or do the tune into the webinar session as soon as they get posted, so that you are caught up with the assignments and are ready to go to the next step. Tips are again posted. Tips for the Sketchpad lessons for this webinar series will be posted around 3 p.m. today. And
Yeah, and just like we said last week, really push yourselves, and I guess what I mean by that is look for things that you can really apply in your classroom. And with Desmos, don't be afraid to try, or any of these things. Don't be afraid to try things out. And like I said, is when you explore beyond what's covered in the webinars, it's like take what you can in the classroom. If you have any questions on how that could be done, or concerns or things like that, please ask us here in the forum or email us.
Absolutely. And again, do share good resources that you find. It is very important if you do a screencast, if you do an assignment that you found especially helpful to your students, I can assure you that it will be helpful to other teachers as well. So it's it's our own professional learning community. So please share, please collaborate, and that would be anything you send us. We will post in the forums and in the joint Google folder, so everyone can have access to it. Again, just a quick view at our learning series objectives. This is how we are moving forward, keeping in mind these big idea objectives, so that we can align more of our work to the DLCS and the Common Core Mathematics standards.
So session 3 will be Tuesday, July 12th. Assignments in the webinar will be posted in the Google Classroom. And again, you probably get tired of me saying this, but August 10th is the due date for all the assignments.
Absolutely. Thank you so much. Thank you again for tuning in. This is, hi, I'm Rashmi.
I'm David Commishlin.
Yes, thank you for watching, and we look forward to receiving feedback and input and all your amazing assignments. Thank you again.
Bye-bye.